Have you ever looked up at the sky and wondered how massive airplanes, weighing tons, manage to lift off and stay airborne? The answer lies in the fascinating world of aerodynamics and the laws of physics. In this video, we'll break it all down in a simple and engaging way. So strap in and let's take off. The law of conservation of energy states that energy cannot be created or destroyed, only transformed from one form to another. Motion is defined as the process of changing position relative to a reference point. An object may appear to be in motion relative to one frame of reference, while stationary relative to another. For example, a passenger seated inside an aircraft traveling at 200 knots is motionless with respect to the aircraft, but is moving at the same speed as the aircraft relative to the surrounding air and the earth. Air has no force or power, except pressure, unless it is in motion. When it is moving, however, its force becomes apparent. A moving object in motionless air has a force exerted on it as a result of its own motion. It makes no difference in the effect then, whether an object is moving with respect to the air or the air is moving with respect to the object. The flow of air around an object caused by the movement of either the air or the object, or both, is called the relative wind. The terms speed and velocity are often used interchangeably, but they do not have the same meaning. Speed is the rate of motion in relation to time, and velocity is the rate of motion in a particular direction in relation to time. For example, an aircraft starts from New York City and flies 10 hours at an average speed of 260 miles per hour. At the end of this time, the aircraft may be over the Atlantic Ocean, Pacific Ocean, Gulf of Mexico, or, if its flight were in a circular path, it may even be back over New York City. If this same aircraft flew at a velocity of 260 miles per hour in a southwestward direction, it would arrive in Los Angeles in about 10 hours. Only the rate of motion is indicated in the first example and denotes the speed of the aircraft. In the last example, the particular direction is included with the rate of motion, thus denoting the velocity of the aircraft. Acceleration is defined as the rate of change of velocity. An aircraft increasing in velocity is an example of positive acceleration, while another aircraft reducing its velocity is an example of negative acceleration or deceleration. The fundamental laws governing the action of air about a wing are known as Newton's laws of motion. Newton's first law is normally referred to as the law of inertia. It simply means that a body at rest does not move unless force is applied to it. If a body is moving at uniform speed in a straight line, force must be applied to increase or decrease the speed. According to Newton's law, since air has mass, it is a body. When an aircraft is on the ground with its engines off, inertia keeps the aircraft at rest. An aircraft is moved from its state of rest by the thrust force created by a propeller or by the expanding exhaust, or both. When an aircraft is flying at uniform speed in a straight line, inertia tends to keep the aircraft moving. Some external force is required to change the aircraft from its path of flight. Newton's second law states that if a body moving with uniform speed is acted upon by an external force, the change of motion is proportional to the amount of the force, and motion takes place in the direction in which the force acts. For example, an aircraft flying into a headwind will experience a reduction in ground speed due to the opposing force. Similarly, a crosswind will push the aircraft off course unless corrective control inputs are made. Newton's third law is the law of action and reaction. This law states that for every action, there is an equal and opposite reaction. This law can be illustrated by the example of firing a gun. The action is the forward movement of the bullet while the reaction is the backward recoil of the gun. These three laws collectively govern all aspects of flight and are continuously at play in aircraft motion. Bernoulli's principle states that when a fluid flowing through a tube reaches a constriction or narrowing of the tube, the speed of the fluid flowing through that constriction is increased and its pressure is decreased. The cambered surface of an airfoil affects the airflow exactly as a constriction in a tube affects airflow. As the air flows over the upper surface of an airfoil, its velocity increases and its pressure decreases. An area of low pressure is formed. There is an area of greater pressure on the lower surface of the airfoil, and this greater pressure tends to move the wing upward. The difference in pressure between the upper and lower surfaces of the wing is called lift. 3/4 of the total lift of an airfoil is the result of the decrease in pressure over the upper surface. The impact of air on the undersurface of an airfoil produces the other 1/4 of the total lift. These principles form the foundation of aerodynamic theory and are crucial to understanding flight mechanics. Thanks for watching.